question which forces you to think but can visually be solved. It says the shortest distance of a given point to a given circle is 4 centimeter, longest distance is 9. Okay, so let's just draw this and see. If I mark my coordinate plane and let's say that this is a circle, right? So I assume the center of the circle is at 0, 0. The shortest distance is 4 centimeters. Let's assume this is my point. So if r is the radius of the circle and x is the distance from the circle to this given point, let us call this as point A, then the shortest distance is 4 centimeters. So x is equal to 4. And the longest distance is 9. So from A, the longest distance would be this point, let us say B. So the distance between A and B is 2r plus x. So 2r plus x is equal to 9. So substituting the values, I get 2r plus 4 is equal to 9. 2r is equal to 5, which implies the radius is 5 by 2 or 2.5 units. So 2.5 is an option. You might be tempted to mark this, but let's think. Why I have an option 2.5 or 6.5, right? There must be something to it. So this is the second case you can think of. In the first case, we assumed that the point was lying outside the circle, but I'm not told whether it is outside the circle or not. What about a point inside the circle? So if I assume that this is the point inside the circle, let us say A, right? Again, the radius of the circle is r. And let me assume that the distance here is x, correct? So the shortest distance, the value of x is 4. So in this case, again, I get x is equal to 4. But what is the longest distance? In this case, B. So 2r minus x. So 2r minus x is 9. So I get 2r minus 4 is 9, 2r is equal to 13, or r is 13 divided by 2, 6.5. So I've got two possibilities. If the point is outside, it could be 2.5. But if the point is inside the circle, radius of the circle could be 6.5. And that is definitely an option available. So remember, think of all the possibilities, and options like these are a clear-cut hint that you have to think beyond the obvious.